Hey, Killis here again. Is poisoning AI a thing, or is poisoning AI going to be a big enough of a problem to where it even causes the progress of this AI development to slow down? Personally, I don't think that it's going to be a big enough of a hit to make any difference at all. I did research the topic, and I did ask the different models what their thoughts are about AI poisoning and the results of protecting against such poisoning. And so that is what this episode's topic will discuss.
They are not hacking the model after it ships. They are trying to spoil the food it eats. One doctored picture, a few hundred web pages. The question for this episode: can you poison an AI, and does it matter enough to slow the whole industry down? Poisoning in the official risk list is an integrity attack. Someone changes the training data, the fine-tune set, or the model file so the system learns the wrong thing or hides a trigger until later. That is not a jailbreak. That is not a prompt trick at chat time. That is the well. The tool most people have heard of is Nightshade, from Ben Zhao's lab at the University of Chicago. It tweaks pixels so you still see a cow in a meadow. The models inside start mapping that picture toward something else. Zhao's own example: the model learns cow and later draws a truck. Artists were supposed to upload enough of these that a scrape becomes expensive. The paper landed at IEEE Security and Privacy in 2024. The tool is real. A confirmed kill shot on a named production image model is not in the public record. Same lab built Glaze, a cloak on an artist's style, more shield than bomb. Spawning, the group behind Have I Been Trained, shipped Kudurru, a network that spots scrapers. You can block them or serve the wrong image on purpose, so in the style of you learns a no AI poster. Two different processes. One edits the file. One lies to the crawler. In 2023, Carlini and colleagues showed you do not need to own a lab to touch a giant dataset. Split view: the URL stays the same, the page changes after the dataset is listed. Front run: edit Wikipedia in the window before a snapshot, then revert. They estimated they could have poisoned 1/100% of LIO and 400M for about $60. They told the maintainers, cheap to inject. Not the same as the big labs are already owned. October 2025. Anthropic, the UK AI Security Institute, and the Alan Turing Institute, in their setup, about 250 malicious documents were enough to plant a simple backdoor in models from 600 million parameters up to 13 billion. 100 documents were not enough. The count barely moved as the model got bigger. That is the line that scared people. Read the asterisk: lab backdoors. Not a proven hit on a 100 billion parameter production run. One more cousin, so we do not mix it up. PoisonGPT 2023. Researchers altered a GPTJ model so it said the wrong man landed on the moon, then uploaded it to Hugging Face under a name that looked like a Luther AI. That is poisoning the download, not the crawl. Same word, different pipe. What this is not: it is not the sandbox escapes from last week. It is not a jailbreak. Sleeper agent papers from Anthropic show backdoors can survive safety training when the lab puts them in. That proves persistence. It does not prove a stranger already poisoned Claude. Ask the squad: is training data poisoning actually possible at a scale that matters? Or is it a lab demo that filters and licensed data already blunt? Training data poisoning remains mostly a lab and small model result so far. Carlini showed it's cheap to poison a tiny slice of public datasets like LION, and the 2025 multi-lab study planted backdoors in models from 600 million to 13 billion parameters with a few hundred documents, but neither case has been confirmed on actual frontier-scale crawls. Nightshade also lacks any documented success against a named production image model.
Training data poisoning remains primarily a lab or small model result rather than a proven practical threat to frontier AI models by 2026. Tools like Nightshade exist, and research demonstrated backdooring smaller models or public datasets, but there's no confirmed proof of successful poisoning against named production models or during 100 billion plus parameter per training.
Training data poisoning has been demonstrated in lab settings and on mid-sized models, up to 13 billion parameters, but there's no confirmed evidence it has successfully compromised frontier models, 100 billion plus parameters, in practice. Attacks like split-view poisoning or document backdoors require careful execution and remain unproven at scale for production pre-training. The threat is plausible, but not yet validated against the largest models.
I'd call training data poisoning a credible research threat, but not yet a demonstrated frontier model killer. We have practical attacks against public datasets, and lab work shows surprisingly persistent backdoors from relatively small numbers of poisoned documents, but that result has not been proven on 100 billion plus parameter production per training. So in 2026, I'd be careful about saying an outside attacker can poison a major frontier model through the open web. We simply don't have that evidence.
Even if it works, is it significant enough to hinder AI progress and growth? Or is it a real integrity risk that does not change the trajectory? I don't know whether successful poisoning would meaningfully slow industry progress or get absorbed by filtering and licensed data, since the available evidence doesn't address that scale of impact.
It's not yet clear if it meaningfully hinders AI industry growth. The available information details attack vectors and feasibility, but doesn't quantify the broader impact on the industry's progress or its ability to absorb these challenges through filtering or curated data. Can't definitively say whether it's an absorbable threat or a significant blocker.
If effective, poisoning could hinder progress by eroding trust in data sources and models, but the industry may absorb it through filtering, curated or licensed data, and increased compute for detection. Uncertainty remains about whether those defenses scale to frontier models, or whether adversarial techniques evolve beyond current mitigations.
Even if poisoning works, I don't think it necessarily stops AI progress. It looks more like a cost and security problem that the industry can potentially absorb. Better filtering, curated or licensed datasets, provenance controls, and additional compute can all make poisoning harder or less consequential, although they also increase the cost and complexity of training. The bigger long-term concern is whether attackers can make those defenses expensive enough to materially slow the rate of progress. We don't know yet.
So the processes are public: pixel poison, style cloak, serve the wrong file to a scraper, change the page after the index, slip an edit into a Wikipedia snapshot, seed the open web, tamper a model on a hub, 250 documents in one careful experiment. Whether that is a pebble or a boulder is the vote. Sources in the description.